Hello, this is a podcast to help you do some of the calculations for your sugar and soda lab using Mathematica. I'm going to skip on down here to the data. What we're doing here is we're cleaning out old variables just in case they're still there. Then what we're doing here is we're giving you some data. We're saying the volume of the water that you're going to put the sugar in is 250 milliliters. The densities of the four solutions are as follows: 1.0157, etc. And those are related to the percent. You got a 4% solution, you got an 8% solution, a 12% solution, and a 16% solution. What I'm doing here now, and I'm using the mathematics that we gave you up top here, is we're coming up with a mathematical equation. This is called a function that will allow me to calculate what the mass of the sugar is for each of the 4 or 5 solutions. So notice that mass of sugar, notice by the way that variable name is all one word and all lowercase. I need to know the density, I need to know the volume, I need to know the percent. And by using the colon equal sign there, we're saying this is a reusable function, meaning this is a function that I can define at one time and then use it over and over again. I'm going to evaluate my whole notebook there. So let me show you how this would work. I would say mass of sugar, and if I wanted to know how much sugar I need for 1.0157, that's my density, and my volume is 250 milliliters, and my percent is 0.04. I would just type those numbers in there, and what that's telling me is I need 10 grams of sugar to make a 4% solution in 250 milliliters of water. Okay, now I can cheat here. Okay, I can do all 4 of them at once by saying what's the mass of sugar of all of my densities, my volume, which is defined at 250 milliliters, and all of my percents. Okay, there I get all my masses. So for a 4% solution, I need 10 grams. I need 20 grams for the 8. I need 31.5 grams for the 12, and 42.6 grams for the 16%. I did the same thing here to calculate my volume. Okay, to calculate volume of water, I would type in the volume of water is the density, so I'll do the first one, 1.0157, and my volume, which in this case is a constant, and that's going to tell me I need 253.92 milliliters of water. Okay, now what I did here, okay, so you don't have to do that particularly. I wanted you to make sure you understand what's doing here, is what I did here is I made a little bit of programming, and I'm going to put a little bit of space here saying C. What you should notice down here with this table, there are 3 columns. So in my table, I have a column that will tell me my percents, and the row there says do row 1, then do row 2, do row 3, do row 4. So this is the start of the row, this is the end of the row. So I'm starting at row 1 and ending at row 4. Okay? So then use my formula, my mass of sugar formulas, to calculate how much sugar I need, and then my third column is going to be this little bit of mathematics where I'm taking my volume of water and I'm subtracting from it the mass of the sugar, and all of that is put in a nice little table here. I'm going to do one more thing here that's not on here. I'm going to do a final solution prep variable, and what I'm going to do is I'm going to prepend, meaning I'm going to add in front to my solution prep table. I'm going to say, in quotes, because these are going to be labels, I'm going to say percents, mass of sugar in grams, and volume of water in milliliters, and I'm putting that all in brackets. Okay. So I'm going to suppress that because I don't need to see it, but down here I'm going to actually grid out my final solution prep table, and I think you can see what I did there. Prepend, by the way, means in front of, pend means add. So I added some labels to my original table. My original table is solution prep, and I added some labels so it looks a little bit nicer, and you can try that if you think you want. Okay. Down here is the data you collected in the lab. So you made a 4% solution, 0% solution 4, 8, 12, and 16, okay? In Mathematica, when you're collecting data, you don't want to put any calculations in your data table. Your data table should just be the data that you collect in the lab. Then you'll use other tables to calculate your results and do that. All right. I'm going to do something here. I'm going to set up a new table called experimental values. I'm going to make this a little bit cleaner, okay, than the one I gave you. So I'm going to come down here and I'm going to insert a new table matrix, and I want there to be 5 rows with 2 columns, okay? And what I'm going to put in here is my data. Now, I'm going to put 1.010. I'm going to put my densities first, and I'm just going to make up some data here. So this is probably not the data that you got for your lab. And you see I'm just making up data here. Okay, so the question is, why am I putting my densities first? Because I want to be able to plot it. And then in here I'm going to put my percentages, and I'm actually going to put them as percentages. It makes it a little bit easier to read. I hope you can understand where that's coming from. And I'm going to suppress that and evaluate it. Okay, now what I want to do now, okay, so that's the first set of data. So I should have collected that data in here. So in the lab, I collected 0.010, I collected 1.020, whatever I collected. What I did here is I just retyped it. There are easier ways to do this, but for now, I'm just retyping it. Okay, down here, okay, I'm going to call this my soda data. And again, I'm going to make a data table there. I'm not sure exactly what you did there. And I'm going to have 4 rows with 1 column. Okay, so I'm going to say 1.050 was my density of the Pepsi. Let's make it something small. 1.05. Okay, my Coke was 0.015. I'm absolutely making up numbers here. 1.01 was my cheer wine, and my Mountain Dew was 1.035. And this is the data I collected in the lab. Now notice I have a data table there with just the data in it. Okay? What I want to be able to do is I want to be able to say 1.005 corresponds to what percentage of sugar. Okay, now, so to be able to do that, what I have to do is I'm going to do what's called a data fit. I'm going to do a y equals mx plus b equation. So I'm going to do linear model fit on my experimental data, experimental values, and I'm basically doing the fit on x. So I get a fitted model here. Okay. All right. Well, how do I use that data? Well, let's do something before we even do that. Let's do a list line plot of my experimental values. Okay. Ooh, bad data point there, wasn't there? Was it 0, 4, 8, 12, 16, 1? Let's make this, let's make that a 5. So my data looks a little cleaner. There we go. That looks a little nicer. Okay. All right. Now, it's a pretty straight line, isn't it? Okay, pretty nice. And we could put some labels on it to make it look a little nicer. Hyphen, greater than sign, and I'm going to put in quotes here. I got densities on the x-axis. If I could type, I'd be okay. I got percents. And I'm putting all of those, let's put some labels on them. Okay, so that's my data from the lab. Okay, now what I'm going to do is I'm going to come down here and I'm going to look at my data. So 1.005, come find that on the graph. Okay, there's 1.005. If I go up and over, what I find is that's what, about a 2% sugar. Okay, 1.015, okay, that's right about there. Go up, go over, that's about a 3% sugar. 1.010, okay, go up and over, that's about a 2.5 sugar, okay. 1.035, okay, go up, go over, that looks like about an 8.5% sugar. Okay, so you see how we're using our y equals mx plus b equation here to be able to predict what the percentage of solutions in here. Now, there's a much easier way to do that. I can actually use that data fit to calculate directly, okay, what my things are here. It looks like I got bad data here. I'm making up bad data. Let me make this. That's what I get for making up data. I'm going to make this 0.01. I made up data here and I got a negative number, okay? So I don't want to do that, okay? So being that you won't get a negative number here because that's not minus 4% sugar there. That should be something a little bit more normal, okay? So you'll have better data than the data I'm making up here, okay? So what you're going to do now is you'll be able to use your data fit. Let's do one that I think will probably work, okay? So there for the 10.0351, I get about 11% sugar, okay? So that's how you're going to use your experimental data. So again, let me go over that again. What you did is you measured these in the lab. You're going to build a new data table with the densities as x, with the percentages y. You're going to plot that data. You're going to do a y equals mx plus b fit. And let me make this look a little bit more normal using the normal command. So it actually looks like a y equals mx plus b. And if you are a traditional kind of person, and you want to see this looking in traditional form where the x is up front, okay? So there's your y equals mx plus b equation. The slope is 400, the y-intercept is minus 404, okay? And that goes from there. Now you're going to use that data fit. You're going to use what you created here and plug in your densities, and that's going to tell you your percent sugar. So that's basically how you're going to do this. Now what you're going to do is you're going to calculate percent error. And what I like to do is I like to create a function where I have my experimental value, and I'm going to put an underscore there. That tells me it's a variable. Okay, and then I'm going to have my true values here, and again, that's an underscore, and that's a function, so I'm going to do a colon equal sign. I'm going to do a control backslash, and I'm going to say experimental minus true values, all divided by true values, and this equation is up above. Okay, I'm going to take the absolute value of this whole mess, and I'm going to multiply it by 100. Okay, and now I can use this, I can say percent error. Okay, my experimental value was 1.01. Okay, my true value was 1.00, and you see I'm getting that from the table. And in this case, I get 100% error. Again, my numbers are all bogus, so don't pay any attention to mine. Okay, you'll get different values. So this is how you do the calculations. Again, let me sort of do a quick review. Okay, all of this stuff up here is the mathematics needed to try to figure out how you prepped your solution here. Okay, 10%, 20%, 30%, 42%. Okay, then I collected data in the lab for 0, 4, 8, 12, and 16. I collected densities. I reorganized that data so that my densities were X, my percentages were Y. I plotted it, and so I got a nice straight line with densities as X and percentages as Y. I did a Y equals MX plus B fit here on my experimental data. I got a function, 400X minus 404, and then I used that function I plugged in all the densities or specific gravity, same thing, of my 4 soft drinks. I put those numbers in here, and that told me the percentage of sugar in the soda. Down here, I simply did a percent error calculation, so I calculated, I should have gotten that as my specific gravity. Okay, when I did it up here, I got 1.01, so I had a lot of error there, but again, I'm making numbers up, and then I'm able to print out all my percent errors. So I hope this helps, and good luck on this. Good luck on this lab.